What's up, nerds? Harbinger here. Today we're going to talk about how the internet works and what happens when you type something in to your computer while being on the internet and how you get the information that you need. So I'm going to start off uh, breaking it down with a picture, and I'm going to throw a lot at you at once. And then after we go through the diagram, I'm going to answer some FAQs because you've got like homework on this stuff, and I want to make sure that you guys are knowledgeable about the topic. So here goes. Sorry for the bad art already. Microsoft Paint is not my best friend, but I don't think this is the worst paint art I've ever done. So I know everybody's kind of like reading this as I'm talking. That's cool. So here's you on your happy computer. I love free clip art. And maybe you want to look something up on your computer. Maybe you're at home and you are remote learning and you wonder, oh my gosh, is tomorrow an A day or a B day or a C day or a D day? Or I wonder what's on the menu for lunch or something like that at school or whatever. These are the layers, these are the processes through which your query goes to get you the information. So hypothetically, maybe you type in like nsesd.org and your computer, it's going to look it up online. The problem is your keyboard operates in terms of characters, and the addresses are really just these giant like numbers with a series of dots. In fact, if you can see, whoops, my head's going the wrong way. Over my shoulder, I've got the 127001. That's an IP address also that we'll talk about later on. But how do we get from the characters in your keyboard to the address and then the information to that address? Works like this. So the very first thing that happens is it goes through the application layer. And I know you can read this, but the application layer kind of figures out what you're trying to do. So if you're trying to do email, like on a like an embedded system kind of thing, not like Gmail necessarily, but if you have like Outlook or something maybe like installed in your computer, I would say, oh, we've got an email protocol going on here. If you're looking up something on the World Wide Web, so you're looking up like ESPN.com or XKCD.com or NSCSD.org, it starts looking to see what kind of protocol it would need. And here it would need like a www protocol. And then it's going to start breaking the message into little chunks. And we call those chunks packets. And if you remember your Create an Internet project, I bet a lot of you did the whole packet thing. You know, you broke it into little pieces. You could transmit it, you know, within the rules. And that's why we did that project, is because it corresponds here. So the application layer is the first thing to break it down into packets. To be clear, the packets can get broken down more and more as we go down through the layers. But for all intents and purposes, let's just say like they're broken down at some point, and it starts with the application layer. So anyway, it goes down from the application layer down to the TCP, which is the Transmission Control Protocol. And that's where it kind of gets like assigned a port. So ports are kind of connection spots in your computer to the outside world. And the TCP's job is to pick the appropriate port. And certain ports are designated for certain functions. And it's going to split up the packets appropriately and send them, or it's going to get them ready to be sent through those ports. So it kind of prepares the packets to be sent. And the IP is the Internet Protocol. So the Internet Protocol, I say it addresses the envelope, but it assigns it like a destination IP address. It's like, hey, we think we know where you're going to go, and this is how we're going to get there. And it looks at like the domain, like a .com or a .gov or a .org, and then it starts looking at other things that go with that. So it gets the packets ready to be sent. It has an address on it. They are like a port. They know where they're going to go through. And the machine layer says, well, I'm going to take all that information and I'm going to transform it into like a physical signal. And that would be like light pulses if you're going to send it with laser beam or something cool like that. Maybe it's electrical currents like pulsing through a wire. But whatever the physical signal is that transmits the messages, that's the machine layer's job. Like it interacts with the hardware. You know, it takes the stuff from the software and it translates it into like a physical transmission, and it sends it. So for some of you, that would be like the tugging on the rope that some of you had proposed, or maybe that would be, I don't know, like waving the wire or throwing a paper airplane. Like you're physically sending the message now. So it goes to a router, and it goes what's called the DNS. And the DNS is like a domain name system, I think, that translates the the website you're looking for, like nscsd.org, into an IP address. So it translates it into a number. So the DNS's job, it's a phone book, and we don't really use phone books anymore, but like 30 years ago, this would have been an apt analogy. The DNS's job is to take a URL like nscsd.org and turn it into a numeric IP address. And so nscsd.org, the numeric IP address for it is not pasting. I actually did look this up, but it's a bunch of numbers, dot, a bunch of numbers, dot, a bunch of numbers, dot, a bunch of numbers. And that makes it easier to transmit. You know, computer systems handle numbers better than they handle letters, so the addresses are usually all numeric. Anyway, after it gets assigned a numeric IP address, it goes through a router, then it goes through another router, and then it goes through as many routers as it needs to go, all these little packets. And they don't all necessarily go through the same routers. Like, a packet isn't guaranteed to take the fastest possible path. It just, all the routers are kind of sitting there, and they take in a packet, and they switch it to another packet. And they're taking them in like, okay, you're probably going to go that way. And, oh, you're going to go that way. And sometimes packets from the same message go in different directions, but they all kind of end up at the same destination. So I know that's kind of weird. You'd think that they go the most efficient way possible. They all kind of go as fast as they possibly can. They're not guaranteed to go the same path. And I hope you're thinking right now, like, that sounds like a heuristic, not an algorithm. So they all kind of get sent to the right spot. They just might take different paths to get there. So kind of a weird concept, but at the same time, not horrible to understand. Like, if you wrote a letter to grandma and you sent it in like 6 different envelopes, like little pieces or something like that, each envelope might take a different path, like if they got split up at the post office or something like that, but they're all going to get to grandma eventually. It happens. And please don't think that you're guaranteed a total of 3 routers or something like that. You could take 10, you could take 100 routers to get wherever you're going. The signals move really, really fast, right? They move pretty much at the speed of light, not necessarily, but for all intents and purposes, it does. Anyway, after it's gone through the routers and it gets to the right spot, we think, it goes back up the ladder. So maybe it's going to interact with the server. Server being like a special computer that its sole purpose is to just hold information so people can get information from it. Maybe it's another computer. You know, maybe it's like a web server that's going to serve up a web page. Like, it's going to send information back to the user about, you know, what images are on the web page or how the web page should look. But essentially, it goes in backwards order. It gets these pulses, it gets these signals, it gets these electric currents, and then it converts it into something the IP can understand. You know, it goes to the right places, and it goes just back up the ladder. Eventually, it gets something that's more usable. And of course, if it has to send information back to the user, like if you hit up a web server, you just went through all this path and went all the way up. It gets to the web server, it gets some information from the server, and it goes all the way back. Like, it's okay to go backwards through this chain too. So sorry for the really weird explanation about, hey, your message goes from your computer down through 4 different protocol layers to a router, to a translation system that changes your address from words into numbers, through more routers, and then backwards through the translation system. And then it might go all that way back in reverse. Oh, internet. Anyway, here's some FAQs. I'm going to ask these on homework, and these are eligible for a quiz. And I'm strongly considering introducing a midterm and putting some of these guys in the midterm. So let's talk about things that people ask a lot at this point. And if we were doing like fully in-person learning, people would be asking smart things like this. We'd be doing more math problems. How many bits are in a byte? There are 8 bits in a byte. So 8 bits in a byte. A bit being a binary digit. You know, it's a 0 or a 1. And so if you have 8 bits, like 10101010, just to make it easy to count, that's 8 bits, and that's a single byte, right? And so it assumes this entire unit is 1 byte of memory, 1 byte of information. All right, so how many bytes are in a kilobyte? Let's do the wrong answer first, and that would be 1,000. People are yelling at home, what? Hey, I learned my metric system, right? There's like 1,000 grams in a kilogram. Kilo means 1,000. Yeah, you're right. Except computers don't work in base 10, right? We don't work in like times 10 to get to the next place. Computers are really good at doubling things. So here's the right answer. It's 1,024. which is roughly 1,000, right? Like that's why we can kind of get away with doing 1,000 math in that sense. And that's because 1024 is 2 to the 10th. So computers are really good at doubling things. They double speeds, they double sizes. If all the binary information is base 2, we'll talk about base 2, doubling suddenly takes on a whole lot more power. And so 2 to the 10th is 1,024. There's 1,024 bytes in a kilobyte. Google tells you get like 1 gigabyte of storage space. And even if your storage space is empty, it says, hey, you have 1,024 megabytes to go, which was kind of a fun surprise. I expected 1,000, and that's not the case. So heads up. The question that goes hand in hand with this are how many kilobytes are in a gigabyte, how many gigs are in a, sorry, I'm saying this wrong, kilobytes in a megabyte, how many megabytes in a gigabyte. I had to go through like my age progression. Like, gee, when I was a teenager, I cared about kilobytes. And then as I got older, then like we dealt with megabytes and then gigs. Like a gig was a very big deal. And now I have an external hard drive that's several terabytes. But hey, Bob Dylan was right. The times they are a-changing. Hey, you have to know byte sizes. What are the 3 byte sizes? So we talked about kilobyte, right? And there's 1,024 bytes in a kilobyte. And how many kilobytes are in a megabyte? Well, there's 1,024 kilobytes in a megabyte, right? So how many megs in a gig? It's not 1,000. Wish I could draw my arrow. There we go. There are 1,024 megs in a gigabyte. And I could ask about terabyte, but you're going to know the answer. So kilobyte to megabyte to gigabyte, yeah, you have to know them in that order. So I don't know if you have like a cute acronym or something like that, but hey, that's what it is. Stomach's growling. I'm sorry if you can hear that. I'm starving. I always am starving. Hey, what's bandwidth? So bandwidth you hear all the time. Like if you've ever seen like a Verizon commercial, they talk about bandwidth. Bandwidth is like the speed limit for your internet access. So ISPs allocate bandwidth. And ISPs, of course, are internet service providers. So maybe you have Spectrum, maybe you have Verizon, maybe you have, I don't know, someone else. But so internet service providers give you bandwidth, like you pay for it, right? And they tell you how much you can upload and download. So they kind of set the speed limit and you can't go beyond that. So maybe you have a bandwidth of, I don't even know what, I'm going to make up a number like 7 megabytes a second or something like that. You could transmit at 3 megabytes a second or 4 or 5 or 6. If you're really lucky, 7 megs a second, but you couldn't do 8, right? Because you've paid for 7 megabytes a second and that's the absolute limit. So that's your bandwidth. So a bandwidth is like a speed limit. Bandwidth equals speed limit. So again, you're not guaranteed to hit it, but you're guaranteed to not go past it. So what's latency? Latency is like the opposite of bandwidth, right? So latency is like your delay. So latency is how long you wait for information to go out and come back, which is, it's kind of called a ping. Like if you ping a system, you want a really small ping value because that means that your information is going where it should and back really, really fast. Like maybe it's 2 milliseconds or 1 millisecond or 0.02 milliseconds. I don't even know what. But if you have like 500 milliseconds, as a latency, like as a ping value, that's a very long time, like half a second to go out and come back. So you can do like 2 things in a video game every second. So imagine you're playing like Rocket League or Overwatch or whatever teens play. I don't know. There's like a new Call of Duty or something, right? Of course there is. There always is. If you can only do 2 moves a second, you're in some trouble. That's like a rough pace. And so that's like a lag introduction. So latency is like wait time. Yeah, it tells lag. Ping is another kind of term for it. It's like a measure of it. Ping is like I said, the time you wait for a signal to go out and come back. And you can do this on your own computer if you know how to use a command prompt, but we just can't do it at school. It's blocked. I already tried. All right, what's scalability? It's our last question. So scalability is the ability for a system to expand and sometimes expand exponentially in order to meet the system's needs. So ability to expand So when I give the example of your create an internet project, some of you had really scalable options and some of you didn't. So for some of you, a scalable model might be one that we could expand to cover Cicero L and Sparrows and Walgreens and like Gillette Road Middle School. And if your system was really good, then maybe like Roxborough Road Middle School might want it because they're a little further out. Maybe East Syracuse wants it. Maybe Watertown wants it. You keep expanding your system, and can you handle the rapid expansion? Some of you could. Like some of your models are expandable, and some not so much. And hey, like my model isn't really that expandable, although I guess I could use like a laser beam instead of a flashlight for the heat model. But sometimes apps have this problem. When a new app comes out, if it's designed to be scalable, means the app is ready to be like go from 10 users to maybe 10 million users really quickly. And sometimes it's not able to. Maybe they don't have the server space. Maybe the UI is kind of complex. Maybe maintenance on the app takes a long time. So scalability definitely determines how fast you can build something quickly. So that's all the notes. You do have homework on this, and it's due right before break. I hope all is well. We're going to talk between now and then. Harbinger out.